I now introduce our first plenary speaker, Lisa Bero, who's a close colleague and friend, has moved from our place, the University of California, San Francisco, to the University of Sydney. She directs the Evidence, Policy and Influence Collaborative Research Program at the Charles Perkins Center. Her subject is Peer Review, Are We Looking at the Right Things? Lisa.
Thank you, Drummond. Thank you, Drummond. And as we all know, Drummond is the driving force behind the Peer Review Congress, and so I think it's only fitting to start my talk with a quote from Drummond, and this was in his Nature article introducing this Congress. So Drummond says, rightly, he's advocated for research to improve peer review and thus the quality of the scientific literature. And much of the research presented at the Peer Review Congress has shown that this causal connection, suggested here between peer review and quality, is really a leap of faith. But that depends on how you define quality. And I define quality as a publication that is not biased in its design, its conduct, or its reporting. So since the start of the Peer Review Congress, it has been contributing immensely to our understanding of the types and sources of bias in the scientific literature. There have been a number of other collaborators on this hunt for bias. For example, the Cochrane collaboration has played a major role in tracking down bias, and in fact, it's the only organization I know of that gives an award for criticizing or recognizing bias in itself. But all of this identification of bias has led to eroded trust in systematic reviews, published research, and science itself. This has left us in a very, very bad place. Science and scientific experts are vilified. What are we as researchers supposed to do? How can we focus peer review on reducing bias and rebuilding trust? So today's theme is problems, and we have lots of them. But the Peer Review Congress has also contributed to not only identifying problems related to bias, but to testing solutions for the problems. I put meta-research up there as a type of solution because it's the only type of work that lets us know what type of biases are occurring across broad areas of research, not just within a single study. And that's the first thing we need to do with bias, is expose it. We've made great progress in terms of protocol publication and open data access and reporting standards to tackle different types of reporting bias. And you statisticians in the audience will be happy to know that I list you as a solution rather to a problem, because your growing role as editors and peer reviewers helps to reduce bias in analysis. But I still think that we have bias in interpretation or presentation of findings called spin, and funding and conflict of interest biases that are not quite being addressed yet. And I will be talking about this later. And the caveats for most of these solutions are that they are often developed for randomized control trials only, and they're not uniformly applied. But another characteristic of all of these solutions is that most of them deal with the problem by the provision of more and more information. So we know that the availability of supplemental files and data sets has been increasing. Asante and colleagues have shown that the number of data sets being shared annually in data repositories has increased by more than 400% in the last 5 years. Annette Flanagan has told me that in 2016, about 57% of major manuscripts reporting original research published in JAMA had online-only supplements. And you'll hear more about this study during the poster sessions at this meeting. And it's not just the number of files and data sets that are increasing, but their sheer mass. Mark Reed, who's a science researcher at the Charles Perkins Center, provided me with this example from one of his typical papers, where he's published a 14-page paper with 86 pages of supplemental files. So more information has also been used to address corporate influence on research. As you see there on the left, we have extensive financial disclosures. This is a typical disclosure statement, but any conflicts of interest in that statement may be hiding in too much information. Despite this, we know that there are also undisclosed ties, and we'll be hearing more about that at this Congress. And as shown on the right, the disclosure regarding religious practices, disclosures may be muddied with information that does not meet the criteria for a conflict of interest. And as we see on the lower right there, even when nothing is disclosed, too much confusing information can be provided about actual, competing, and potential interests. Oh, sorry, I ran off my box there. So disclosure of financial ties is insufficient to manage conflicts of interest. We have shown that undisclosed ties remain, and disclosure is difficult to enforce by journals. Disclosure does not prevent bias in research. In fact, all of the research done on bias has been done based on what's been disclosed. It makes those giving advice more biased, as has been shown in psychological experiments from Lowenstein and colleagues. And as the BMJ presented at this conference years ago, if you put funding disclosures on a paper, it does make the readers more critical, but they're as likely to believe the findings. And I know there'll be more presented along these lines by BMJ at this meeting. So in summary, disclosure is not a management strategy, and it's necessary, but not sufficient. We also have more and more information on funding sources of studies. So a number of systematic reviews across a wide range of topics, including drugs, tobacco, nutrition, and chemicals, have shown that funding source is associated with biased results and conclusions. For example, on the left, this recent Cochrane review included 75 studies that examined the association of pharmaceutical industry funding with the results of drug studies. And this is just one meta-analysis from that Cochrane review showing that industry-sponsored studies more often had statistically significant favorable efficacy results. But the meta-analysis on the right shows that the conclusions of food industry-sponsored studies favor the products made by the sponsoring company. Veronica Yank at a previous peer-reviewed Congress also showed that industry funding of meta-analyses was associated with disagreement between results and conclusions, and the conclusions were more favorable. And in fact, the association of funding source with conclusions of studies has been studied far more often than the association of funding source with the actual results of the studies. And this may be because spin can occur. The conclusions of studies can be easily manipulated through bias, presentation, or interpretation, and you're going to hear a lot more about spin at this Congress. So in sum, the provision of more information has made little headway on tackling our problems related to conflicts of interest or spin. More information has actually led to more problems. There may be too much information to be peer-reviewed, and we don't really know what's peer-reviewed or not, although we'll be learning a bit more at this meeting. So the bottom line is that peer review has gotten harder, and there's more of it to do, but what do we really know about peer review? Oh, and there is more. I forgot to mention that even after your paper is accepted, you're asked for more information. Authors are asked to provide images, web links, photos, biographies, etc. And this is actually more opportunities to spin the results of your paper. So now I'll move on to what do we know about peer review. So the first thing we know about peer review is that we believe in peer review. In general, scientists think that peer review is a good thing, although young scientists are less likely to hold this view. Peer review is still the gold standard of scientific publication in a variety of academic and policy settings, Peer-reviewed publications are valued more for promotion and tenure. Regulatory agencies often allow only the submission of peer-reviewed articles as scientific evidence. And even corporate interests have learned that publishing their science in peer-reviewed journals will give it credibility. This is an interesting document from the tobacco industry, where someone from Philip Morris was taking notes on a presentation I gave at an earlier peer-review congress. This presentation was on publication bias. And the tobacco industry person taking the notes didn't think much of my presentation, but the point here is that it notes that tobacco industry-sponsored work must be of high quality and must be published in the peer-reviewed literature. So there was recognition that this is what gave the tobacco industry-sponsored work credibility. So we believe in peer review, but we're still not quite sure what it is. At an earlier peer review congress in 2001, my colleagues and I presented a proposal for structured reporting of peer review, which was to have those elements shown there on the left. However, recent papers have noted that detailed descriptions of peer review are still sparse, so our recommendation never really caught on. And the reason we made that recommendation is we were having a hard time figuring out what peer review was happening at journals. My understanding of open peer review, for example, is that the identities of the authors and peer reviewers are known to each other. However, a recent systematic review found that these definitions were often contradictory and overlapping, and in fact, there were 200 definitions in all of open peer review. So now I'm very confused after looking at that. And this is made worse by the fact that there are many, many types of peer review. We have preprints, which are sold to authors as manuscript marketplaces or a place to get your manuscript snatched up and published, on to post-publication review, cascading review, portable review, my understanding of which is that's basically outsourcing of review that's not done by journals at all. So although a lot of energy has been devoted to testing these different models for peer review, it's unclear what unresolved problems we're trying to solve with these models. So I'd like to know how these models are combating conflicts of interest or spin, for example. We also know about peer review that it takes time, and again, I show a quote from Drummond. I couldn't have said it better myself. Good peer review does take time. And we know a lot about the process of peer review, everything from major and minor changes to suggested, to how long it takes, the quality of the reviews, the cost, the time, etc. And in general, these are what in clinical medicine we would call surrogate outcomes, the characteristics of the reviews and not of the papers themselves. So it would be good to see more research focusing on the papers. And lastly, peer review can go very, very wrong. What this figure shows here, if you use the citation rate that Drummond was mentioning, which is still controversial, but here I'm using it as a proxy for paper quality, in our prospective study of over 1,000 manuscripts submitted to 3 high-impact journals, we followed these manuscripts to see what happened, even if they were rejected from the journal. And as you'll see here on the right side of the figure, the red dots show the 14 most highly cited papers. And those 14 most highly cited papers were rejected initially by these 3 journals and published elsewhere before they became the most highly cited. And we also know about other problems. There's problems with stolen papers, stolen ideas, or my favorite was a pre-embargo leak of one of my accepted papers by an industry-affiliated reviewer. So I suggest refocusing research on peer review towards tackling some of the biggest and most enduring problems we have with scientific publication, and 2 problems that have not been solved by the provision of more information. These are conflicts of interest and spin. So funding bias and conflicts of interest are a problem because I've already mentioned there's a great deal of evidence suggesting that these biases exist even when you control for a myriad of factors such as the methodologies of the papers themselves. We also have more disclosure, although it's still far from 100%. As I mentioned, we know that disclosure does not reduce bias, and we see high-profile research funded by companies or conducted by investigators with financial ties to companies. And as I've written with Quinn Grundy, these financial influences have a megaphone effect because they can bias multiple aspects of the research in the same direction and affect multiple individuals in the same way. So what can journals and peer reviewers do to stem this avalanche of industry-induced bias? First, they could stop publishing industry-sponsored research, or at least studies that are largely conducted for marketing purposes. And I know that over the years, many journals have discussed better ways to identify, for example, seeding trials or drug trials that are used primarily for marketing purposes. And this suggestion is often dismissed, but it's really not so radical because this has been done for tobacco industry-sponsored research, which a number of journals do not publish. Second, we could penalize authors and companies for not accurately disclosing financial ties. Although we have more and more databases in which to look for financial ties, these do not cover all researchers, nor are they comprehensive, and we still don't know the denominator of undisclosed ties, but we know there are undisclosed ties, and there appears to be no consequences when these are not disclosed to journals. Next, we can provide information on funding sources and all disclosures to peer reviewers. This is not done across the board by all journals. And then we can require peer reviewers to use a tool to assess funding disclosures and author conflicts of interest as risk of bias, just as journals often provide tools for assessing methodologies of the papers. Peer reviewers should then comment on how they think these biases might affect the design or analysis. And for studies with financial ties, we could recruit specialist reviewers to pore over the design, the data, and the analysis. This is already done by a number of organizations that review drug trials, for example, the Pharmaceutical Benefits Advisory Committee in Australia. And as Sue Hill showed in a 2000 analysis of these applications, this committee, with paid experts with data already organized for it, were unable to complete reviews in less than 2 weeks. So this does not solve the time problem, and it doesn't look at the conclusions of papers. So it fails also to address the problem of spin. So I've already defined spin, and as we'll hear later today, there are actually many, many definitions of spin out there. And we still have questions about where spin comes from. Mostly individual characteristics of investigators and studies have been examined in relation to spin. However, systemic problems that may promote spin are rarely addressed, and one problem that is very rarely addressed to my knowledge is whether peer reviewers can catch spin and the role of editors and journals in assessing spin, or in fact, in even contributing to spin. I'm sure many of you as authors might recall the time when someone has asked you to add an alternate interpretation or additional interpretations to your conclusions, which you might have felt was being asked to spin your results. So what can journals do about spin? We can develop checklists for spin that's applicable to all types of studies. I know that there's some work on this for trials, but not for other studies. We can have reviewers spend their time reviewing the methods, the results, and the supplementary files. As I noted, this takes time, but then we could leave the conclusions for editorial review, for example. But before that, we'd need to know a lot more about the editor's roles in spin. We could get rid of discussion sections altogether, although this certainly wouldn't eliminate interpretation in your study analysis. And so a more practical suggestion might be to publish multiple discussions. And many journals doing open peer review are already doing this. They're inviting multiple interpretations of their data. But when we do this, we need to be aware of the megaphone effect, because the interpretations that are published may be those that express a dominant, conflicted view. So these reforms, and I think experimenting with them is very worthwhile, but these reforms would be the death for journal articles and many journals as we know them. And now the death of journals has been predicted by many, including myself, over the last 20 years, and so you can see I'm not very good at predicting the future. But as we move through this meeting, I hope we see more bold suggestions for tackling some of our unsolved problems with peer review. Thank you.
That was terrific. Excuse me. We're going to have no questions today because I had to give that stuff at the start. And you'll have plenty of time to ask Lisa stuff. Mike Berkowitz has something to say at this point about Mike, come out from your burrow. It's where I keep him. Thank you.